Okay, good afternoon, class. So at this point we had our homework. Our homework was on page 267, number exercise 5, number 3 onwards. No? That's correct? Or 2 onwards? 2, not 3. Okay. Why do I think I did number 2? You started it. Okay, let's see. But if we haven't done it, we'll do it this way. Did I cut it already? Nope. Did I say you must do number 2? Normally I don't do number 2. But okay, let's see. Alright, so we are told that AD is a diameter. If AD is a diameter, what do we know? Angle C is 90. Why? Angle in? Angle in a semicircle. Then we are told that AE is perpendicular to BC. AE is perpendicular to BC, which means to say E2 is 90. Not so? E2 is 90. Doesn't look like I marked the proper one thing, but that E2. There we go. Okay? Then we are told that AB, AD, AC and BC are chords. We are required to prove that AB, so let's see, AB over BE and AD and DC. Can you see the triangles you're going to work in? It's going to be in triangle. This one here, which is, sorry, ABE. Not so? ABE and triangle. This triangle here. Sorry? ADC. The order is not in the right order. Why am I going with those triangles? So that I can pick up the lengths they are referring to. You guys understand? So where do I start? Already that 90 degrees. So let's go after that first. So we're going to say that is 90 degrees. Not so? I can either say C1 plus C2 is 90, or I can say ACD is equal to 90 degrees. Why? It's angle in semicircle. Okay. Now what? We know that E1 is also 90 degrees. Not so? Why is E1 90? Because it's given that AE is perpendicular to BC. Okay? Now we need another one. Another angle that's equal. A1, yes? It's A2. Where are you getting that from? It's on the diagram. It's given to us. So angle A1 is equal to angle A2. It is given. Okay? So in conclusion, what can we say? What is the last angle that we need to work with here? Angle B, of course, has to be equal to angle D. Why? It's the third angle of triangle. Okay. Otherwise, I could have gone with the butterfly or bow tie story, isn't it? So that would have also been equal. Angles in the same segment. If I was this examiner, I wouldn't even have given that. Let the learner go with that rather. And let the student rather conclude that A1 is equal to A2 because of the third angle of the triangle. Because this was sufficient information there to have concluded congruency without stating that. You understand? But it's linear. So, was loving for it? Considering your feelings. No? Right. So is that enough to conclude congruency and similarity? Yes. So we can say this is going to come at the bottom here. No? You don't write it on top here. Comes here at the bottom. You say that therefore triangle ABE is similar to triangle. So here you go. A of ABE of this triangle is equal to which of the other triangle? A. So it's going to be A here. B of this triangle is equal to what of the other triangle? D. And then E of this triangle is equal to angle ACD, which is angle C of that triangle. Not so? And the reason is angle. Okay? You guys understand? You all with me? Alright, so what can we conclude now? You can say therefore AB over AD is equal to BE over DC equals AE over AC. Why? Sides in proportion. Sides are in proportion. That's your reason. It goes next to it here. Okay, because of the space in the calculator there, I'm not putting it there, but it actually belongs next to it. It belongs here. That also belongs here. But it's now behind the stuff on the side. Okay. That is your reason there. But let's see what they wanted. They wanted AB, we got AB, and BE. So it's definitely that. They got AD and BC. But what do we know is that B is at the bottom. So I can conclude therefore AB over BE equals AD over BC. Okay. Now something like this worth 6 marks, people. Okay. 6 marks. Remember, you're going to write on proportionality and similarity in your next exam. Okay. You only wrote proportionality in this one. But you guys have a plan, no? Don't you have a plan for yourselves? Huh? Plan to do well in maths? No? Yes? Okay, good. People, very importantly, no? Don't leave all your math study work and all of those towards your final exam. You must try and sort out your issues now. Okay, so that you can benefit from that information in your June exam, again in your mock exam, and in your final exam. Okay. In number 3, we are told that PT is a tangent to the circle BAT at BAT. Normally they would say at T. But if there's a tangent, what do we know? If PT is a tangent, what do we know? T2 is equal to B. Then we are told that BA is produced to P. BA is produced to P, so it's extended to P. Oh, I wish we were in grade 9 again, huh? Yes, when maths are so exciting. Okay, where were we now? TB is join. TB is join. TB is join. AT is a chord. AT is a chord. It's a line. Prove that. So they got BT. So we got BT. This length here. BP, which is this whole length here. Yes, Michael.
Accidentally took the maths file.
And you got the other file in the cupboard.
No, sir.
You know where you must go? You know where it must go?
Yes, sir.
Okay. Then they got AT, which is this here. Not so? And PT, which is this one. So which triangles do you think we're going to work in? In triangle, yes? TP, B, TPB, TPB, and triangle T, A, P, B. If you go here, no? That is the one triangle. You agree with it? So I picked up that side, I picked up this side, and I picked up this side. And you're saying the other triangle is this one here? This one here? Yes, you're right, you're right. So I thought you were going with the other one. You're absolutely correct. Triangle T, P, A. There we go. So what can we say about the two triangles? Remember, this is the one triangle, and this is the other triangle. What can we say? T2 is equal to angle B, which is correct. We have highlighted that already. So angle T2. What's wrong with me? T2, many things. No? T2 is equal to angle B. Why? Tan chord. Right, what else do we know? Angle P is common, it's in both triangles. So common angle. And the last one? A1. So remember we have accounted for that one there. So you're saying that A1 is equal to, so that's the third angle of the triangle. A1 is equal to angle of the big triangle. It's this angle there. Not so? T1 and 2. Okay? Or you could have called it BTP or PTB, or whatever you want to say. Okay? And the reason here is going to be the third angle of triangle. So is that enough to conclude similarity? Absolutely. So now we say in triangle, sorry, not in triangle. Therefore, triangle TPB is similar to triangle. So we go TPT, which is a big triangle. It corresponds. Angle T corresponds with angle A. Angle P is the common, so angle P corresponds with angle P. And B corresponds with T. And what's the reason here? Angle, angle, angle. Okay. So what can be concluded from here? We can say that TP over AP is equal to PB over PT equals TB over AT. Why? Sides, corresponding sides in proportion. Corresponding sides in in proportion. Okay. But let's see what they want. They want BT. They want BP. They want AT. And they want PT. Exactly those two. TP. Here's another TP here. And another AT here. No, AP. We wouldn't have gone with this one because there's an AP here. Can you see that? So, BT is on top. Yes, it's on top. Over. BT is over. So that one must go out under, that must go up. You guys understand? So there you can conclude, therefore, AT over PT is equal to TB over BB, BP. I think I made a mistake. They got BT over BP. Yes, it's right. BP. It's just that I got the other way around. They got BT over BP is equal to AT over PT. Yes, it's correct. Now you guys understand? You okay, Michael? It's boring? Do you understand it? Okay. Alright, let's carry on. The next one is number 4. Another 6 marks, people, if that question had to come in. 6 marks. That's a lot of marks for us. No? We did that one. Let's look at number 4. So here we are told that AOB is the diameter of the circle center O. AOB is just diameter of circle center O. What can be concluded from the C1 is 90. Why? Angle incidence. Then we are told that chord AC produced meets tangent BD. So they're telling us it's a tangent. Chord CB. AC meets tangent at D. So if that's a tangent, what do we know? If that's a tangent, what do we know, people? Yes, what do we know? P3 is equal to angle A, tan chord theorem. Not so. And this is the radius. And it's a tangent, so that P1 is going to be 90. Radius perpendicular to tangent. Or diameter perpendicular to tangent. And meets tangent BD at D. BC is joined. Prove that AB squared. So if you're looking at AB squared, that means to say that AB is used twice. Can you see that, people? They got AB, they got AC. Where's AC? This one here. Then they got AD, which is that length here. You see the two triangles they're working in? So let's say in triangle, which triangles they're working in? A, BC, which is this triangle here. And triangle ABD. They want AB twice. That's why I'm trying to make 2 triangles with that in it. Okay. So what can we say? Where can we start? We start by saying angle C1 is equal to 90 degrees. Why? Angle in semicircle. Then we're saying that this angle there is 90. Not so? So it's ABD. And why is that 90? Radius perpendicular to tangent. So therefore, angle C1 is equal to ABD, which is equal to 90 degrees. I don't think I did this conclusion in the previous one. Did I leave that out? Yeah, you had to say, no? Otherwise, you're not linking this here. Yeah, I had to say that ACD is equal to E1, which is equal to 90. This is what is linking that angle together. Okay. Sorry about that. Slipped my mind. Okay. Let's look at the next one. It was B3. Was it B3, no? B3 is equal to angle A. Why? Tan chord theorem. Okay. So which angle is left out or needs to be accounted for? Intra-angle ACB is B2 is equal to angle D. You all agree with that? B2 is equal to angle D. Why? The third angle of triangle. But don't we have a common angle there also? Would have been A, but I used A otherwise.
So,
Yes?
can B2 and B3 be
B2 and 3.
And it's 10 radius and no 10 then A becomes a common angle.
I don't understand. I'm not following what you're saying. Say again?
So I'm asking if B2 and 3 equals 90.
B2 and 3.
Yes, sir.
This 90?
With the reason 10 radius.
Yes. That is your radius. That is your reason.
Oh, we didn't do that, sir.
We said radius perpendicular to tangent.
For, we didn't say for B2 plus.
A, B, D is B2 and 3. This is another way of writing B2 plus 3 or B2 plus B3 or ABD or DBA. It's all the same thing. Okay. But I'm just seeing why are we not picking up that to be a common angle? Yes?
Why are we using
B?
B3?
Yeah, that's a mistake. Absolutely. Because I'm looking at the wrong triangle here. We're in this triangle here and that triangle. B3 is unnecessary. Not so? So that is wrong. We needed a 90. The 90 is correct. The problem is here. Right, let's go again. Thank you. Okay. Right. So we're saying that is 90 and that was 90. Then angle A is a common angle. Angle A is a common angle, so in conclusion, therefore, this angle D of the big triangle is equal to angle B2 of the small triangle, not so? B2. Why? Because of the third angle of triangle. Okay, then you can say therefore triangle ABC is similar to triangle. So we got A, B, C. So it has to be, A is in both. So it's A, it's common. Angle B corresponds with D. Not so? And angle C corresponds with angle B. Okay. And the reason here is angle, angle, angle. So from here we're going to conclude that AB over AD equals BC over DB equals AC over AB. Why? Sides in proportion, or the corresponding sides in proportion. Not so? Or we can say that similarity. Again, the space is not allowing me, but I would write that as your reason. So let's see what they want. They want AB squared. So I must use AB twice. Can you see that? So in other words, it's that ratio and this ratio is what we need. Okay, so what do? We cross multiply. So AB times AB, AB squared is equal to AC times AD. And that's what they want. Okay. Again, people, almost 7 marks. I think it's 7 marks in this question. 6 or 7. Okay. You look at number 6. Number 5, sorry. Okay, so I'm not going to minimize the diagram, so the diagram is fairly busy. Right, so at this point, let's first go through what is given. Okay, behind. You have to because the calculator is in the way. We don't need a calculator, no? Is number 5. Okay. So we are told that ABCD is a cyclic quadrilateral. So if ABCD is a cyclic quad, what do we know? ABCD is cyclic quad. What can be concluded from that? Yes? C2 is equal to angle B1. Why? Angles in the same segment. That and that is equal angles in the same segment. Those two are equal and those angles are equal. Okay? You also know that opposite sides are supplementary, which means to say they add up to 180. And the exterior angles equal to the interior opposite, which we don't have. Okay? Then we are told that, so I'm just going to make one marking here. This one here, and that one there. Okay. Then we are told that AC and BD intersect at P. AC and BD intersect at P. Yes, that's fine. Then we are told that E is a point on BD. E is a point on BD such that AE is parallel to BC. If lines are parallel, what do we know? Alternate angles are equal. Corresponding angles are equal. Co-interior angles are supplementary. But importantly here, what I want you to note is that that angle E1 is actually equal to D2. What else do we know? You can see that C2 I've marked. C2 is actually also equal to A2. Alternate angles are equal. Okay, so what I'm going to do is I take it off. So I'm going to put those two marking, one marking in. Okay. Sometimes I will do a marking and it was unnecessary to mark it. Okay. But that is just for us to see and give us at one glance which angles we know at this point. Then we tell that you are required to prove that AP over. So if you go here AP, the length AP, which is this one here, PC, that one there, PE, that one there, and PD, this one there. Can you see the triangles we're going to work in? Which triangles are you going to work in? In triangle A, PES, and triangle DPC. Not so? So what can we say in the first account? Sorry? A2 is equal to angle C2. Yes, why? A2 is equal to C2. Because of alternate angles with DC being parallel to AE. Does it make it bigger? Because I've stated it now. What else can we say? Sorry? D2 is equal to A1Y. Sorry? E1Y. Alternate angles. Okay? Or we could have said angle P1 is equal to angle P3. Why? Vertically opposite. And what you guys said was E1 is equal to angle D2. It's either the third angle of a triangle, or you're going to see alternate angles with DC being parallel to AE. So let's then from here we can conclude. Therefore, triangle APE is similar to triangle. So APE is a triangle on this side. So A corresponds with C. P corresponds with P, of course, with vertically opposite. And E corresponds with angle C. Not so? No, angle E corresponds with angle D. And what's your reason here? Angle, angle, angle. In conclusion, we can now say that AP over CP is equal to PE over PD equals PE over CD. Why? Because the corresponding, so AE, this is wrong, the first one. AP, the last one, you say must be AE over CD. Corresponding sides in proportion. Thank you. No? So let's see what they want. They want AP, they want PC, they want PE and PD. So that's exactly what they want. Not so? So you can just say therefore AP over CP is equal to PE over PD. Okay? You guys understand? So let's go to the B part of the question. Remember all these angles are now equal, and so now make another marking there. Then in the B part of the question, they want you to prove that AP squared is equal to that. So AP squared is going to be this then. PB. BP. This one you're using twice. BP, which is this length here. And PE, which is this length here. Can you already see the triangles you're going to work in? Yes. Which triangle are you working in? Is in triangle A, P, E, and A, P, P. I'm picking AP up twice. Okay. So I'm going to just take this off here. It'll probably be a mistake, but okay. I would probably need the ratios again later. Sometimes we use the ratios again. So we said in triangle, this is now for B. In triangle, you said APE, and triangle APP. Right, so what can we say? Sorry? What can we say, people? That P1 is a common angle, not so. I think we must always start at the common angle. Okay, that's a common angle. Alright, what else do we know? We can prove that A2 is equal to B1. Not so. We can prove that A2 is equal to B1. Have we stated at this point already? No. So we must state it first. So we know that angle B1 is equal to angle C2. Why is B1 equal to C2? So, not alternate angles. Angles in the same segment. And it's coming from arc AD. We don't have to write the arc's name, okay? So therefore, A2 is equal to B1. So it's already now marked the same. Can you see all have dots in, so it has to be the same. Okay? What is the third angle there that we need to state? Sorry? We got A2, we got P1, E1. E1 is the other one. Therefore, angle E1 is equal to angle BAP. Not so? Because we got this triangle here. We got that one to common. We mentioned that one already. So that's the other angle we haven't mentioned. Okay. So it's going to be your third angle there. And what's your reason here? The third angle of triangle. Okay. So that's enough to conclude. Therefore, let's take this up a bit. We can say therefore, triangle APE is similar to triangle. So APE, the small triangle. So A corresponded with the whole angle here, APE, the small triangle. P is the common one, so P is in the middle. A of the small triangle, which is A2, corresponds with angle B. And then E corresponded with the whole angle of AD. Not so. BAP, which makes it. Okay. And the reason here is angle, angle, angle. So from here, what can we say? we can say that AP over BP is equal to PE over PA equals AP over PA. And your reason here is that triangles are similar. You write the whole reason in there, or you write corresponding sides are in proportion. Whichever one you want to write. So they want to know AP squared, so you must pick up that twice. Yes, I wrote it wrong, no? Making a lot of mistakes today. That shouldn't get upset when you guys write what you write in your exam, no? So, okay. AP over BP equals PE over PA equals AE over PA. Right, let's go again. They want two APs. So there we go. Can you see that, people? So let's multiply. What's AP times AP? AP squared is equal to BP times P. And that's what they want. Okay. Is that the last one or is there another one? So it turned out we actually didn't need this. Some like this, well over 10 marks. Okay. Why? Because here we had to derive two triangles on our own. Okay, in examination they won't give you two to derive. One is enough for 6 marks already. We learners just leave it out. It's either they leave it out or they get 1 mark out of 6. But you guys are much different, man. No? Not so. You guys are going to nail it. Although you're not working at maths, you're going to, do well. You see, I must be more positive with you guys. Okay, I think we're going to stop here today. What do you think? Why did they put maths last? Huh? Right, so I think I must do one more. I'm feeling bad now. You said yo? Okay, I think tomorrow we're going to do the last few, okay? For those of you who didn't do it yet, please complete these sums for tomorrow. Why is it driving so early? Oh, register. People enjoy the rest of your day? Yes? The homework is a reminder of that exercise. Did you complete it already? Oh my word, how much enough here?